Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have a square root of a is equals to minus a, and we solve this problem for all the values of a. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further, we solve this problem for two methods. I hope so you like both of these two methods. But if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move towards the solution of this problem from first method. So in the first method, here we move this minus a to the left hand side, and when we move this to the left hand side, it will be written as a square root of a plus a is equals to 0. And now in the next step, here we use the nice radical rule. You know about that. If we have a number a in a number x, so we write this x into the form of product of two radicals. Okay, we write this x as square root of x multiplied by square root of x. Okay, we know about that. The square root of x times square root x becomes here x. So according to this rule of radicals, we write this a as into the product of square root of a into square root of a. So according to this rule, we rewrite our above equation as in this form. So first we have this is square root of a plus, we write this a as in the form of square root of a multiplied by square root of a, and this whole equation is equals to 0. And now in the next step we need more simplifications, and here we will take common square root of a. You know that square root of a is lies on both of these two terms, so that we take common square root of a from here. And when we take common square root of a, we get the remaining values are from here we get 1 plus from here we get square root of a, and this whole equation is equals to 0. And now in the next step, we need to divide this equation into the two cases. The first case is we write square root of a is equals to 0, and the second case is we write 1 plus square root of a is equals to 0. So for the values of a, we need to take a squaring on both of the sides, and when we apply squaring, it will becomes here square root of a whole square equals to 0 square. And in this case, we move this plus 1 to the right hand side, and we get square root of a is equals to minus 1. And further in the next step, you see that these 2 and square root are gone, and we get here our a is equals to 0 square becomes 0. So this is the value of this is the first value of a which we get here from first method. Now and now here for the second value of a, we take squaring on this term on both of the sides, and after taking squaring, it will be written as minus 1 whole square. And now again you see here these 2 and square root are gone, and we get here a equals to, this is minus 1 square, and minus 1 square becomes here plus 1. So this is the value of a, second value of a. So here in the first method we get these are the two values of a, and now here in the next step we need to verify that is these values of a be the solution, or is these values of a be the extraneous root. So for verification of these values, we need to copy down given question statement. Here it is square root of a is equals to minus a, and in this side we will be verify a is equals to 0, and in this side we will be verify a is equals to 1. So first we focus on a equals to 0, and we substitute a equals to 0 into the given question statement, and it will be written as square root of 0 is equals to minus 0, and we have square root of 0 becomes 0, and 0 is neutral, it is not positive or negative, so we write here only 0. So this means that both of the sides are equal, and if both of the sides are equal, this means that the value of a equals to 0 is satisfied our given question statement. And now in the same pattern, we verify a is equals to 1, and for a equals to 1, we substitute a equals to 1 on both of the sides, and it will be written as square root of 1 is equals to minus 1, and we know that square root of 1 becomes 1 equals to minus 1. So you see here this is a not possible case, because positive 1 is equals to negative 1 is not possible. So if this is not possible case, this means that the value of a equals to 1 is not satisfied our given question statement. We conclude about that a equals to 1 be the extraneous root of the given equation. Okay, this is the extraneous root because it does not satisfy our given question statement. And we finally conclude about the solution set of this problem is so because a equals to 0 is satisfied this equation, so finally we get a equals to 0 be the only one solution of the given equation. And now here this is our first method, and now we move towards our second method. And in second method we need to copy down given question statement here, so that our given question statement is square root of a is equals to minus a. This is the second method, and in this method we just directly take a squaring on both of the sides, and in that way we find again the roots of this equation. So in the second method we take a squaring on both of the sides, and after taking squaring it will be written as in this form. And further we have this a2 and square root are gone, and we get here a is equals to this is minus a square, and we know about that minus a square becomes a positive a square. And now we move this a from left hand side to the right hand side, and it will becomes a square minus a, and this whole equation is equals to 0. So now you see here both of these two terms involve a, so we take common a from here, and when we take common a we get the remaining values are a minus 1, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write a equals to 0, and the second case is we write a minus 1 equals to 0. So this is the first root of the given equation, and from here we move this minus 1 to the right hand side, and we get a is equals to plus 1. So in the first method we already verify that a equals to 1 is not satisfied our given question statement, so we call that a equals to 1 be the extraneous root of the given equation, because it does not satisfy our given question statement. And we see that a equals to 0 is satisfied our given question statement. So we conclude about that the solution set of this problem is a equals to 0, because a equals to 0 is clearly satisfied our given question statement. So this means that in this problem we have only one root of the given equation, only one solution of the given equation, and that is a equals to 0, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.